So this video will cover Argand diagrams and the modulus of complex numbers. So there's two different topics within it. We're going to start with Argand diagrams. This might sound like a new thing, but it's actually something you've got lots of practice with already. And we're just applying it to a slightly new context. So an Argand diagram is basically just a graph. Now we've all seen one of these before. The graph has two axes, an x-axis and a y-axis. The only difference for an Argand diagram is that we're going to get rid of our x and y axis. Now, where we used to have an x and y axis, we're instead going to rename them the real axis and the imaginary axis, like this. Now, sometimes you will see the real axis just being called RE. Obviously, that stands for real. And the imaginary axis being called IM. Obviously, again, standing for imaginary. So now that we've established our real axis and our imaginary axis, we can try filling in some complex numbers onto our Argand diagram. So our first example will be 3 minus 2i. So on the real axis, it's going to be 3, and on the imaginary axis, it's going to be minus 2. So we know that 3 is the real part of this complex number, and minus 2 is the imaginary part. So we'll go to 3 on the real axis. And we'll draw a line down from there. And then we'll go to minus 2 on the imaginary axis. We can draw a line across from here. So this will give us our point here. 3 minus 2. Again, if we link this up to the real axis, we can see this point is 3 on the real axis. We can see the point is minus 2 on the imaginary axis here. So I'm going to give you another point now, and you can tell me where this would be. So the complex number I'm going to give you will be minus 4 plus 5i. So you can pause the video now, try and identify where that will be on the Argand diagram, and press play when you're ready. Okay, so we're minus 4 plus 5i. To plot this, we're going to go to the real axis first of all, and go back 4. So minus 4 is here. Okay, we'll draw a line from there up, because we know the next number is going to be positive. So then we go to our imaginary axis, and the imaginary part of this number is plus 5. So we're going to go to plus 5 on the imaginary axis. We'll draw a line out from there to meet our part on the real axis. So this number meets up with minus 4 on the real axis and plus 5 on the imaginary axis. So it's going to be drawn here on the Argand diagram. Finally, I'm going to draw a point, and I want you to tell me what complex number the point represents. So I've drawn the point here. We can call this C. I want you to tell me what complex number that point C represents. And you can pause the video now, and when you're ready for the answer, just press play. So our point C, if we try and figure out what the coordinates are, we need to find out its real component. So we'll bring it up to the real axis. We also need to find out its imaginary component, so we'll bring it over to the imaginary axis. So on the real axis, its value is minus 5. And on the imaginary axis, its value is also minus 5, coincidentally. So when we write out the number, the real part is going to be minus 5. And the imaginary part is also going to be minus 5. So it'll be minus 5, which is the real part, and minus 5i, the imaginary part. So we can say that's the value of C. So now that we understand Argand diagrams, it's a good time to have a look at the concept of a modulus. Now the modulus is just a way of comparing complex numbers. Because they're so different to us, and we're not used to seeing numbers in this form that have a real and imaginary part, it can be useful to just think of them in terms of their modulus when comparing them in terms of their size. So a modulus really just means, on this Argand diagram, how far away from the origin, from the 0, 0 point are they? So if we draw a line connecting all of these to the origin, we can probably make a guess at which one is furthest away from the origin. So it looks to me like C is furthest away from the origin, so we could say that has the biggest modulus. It also looks like this point here, and we can call that A, is the closest to the origin. So we could say that this point A has the smallest modulus of the three numbers. And then B, of course, would be somewhere in the middle, so its modulus would be quite big, but not as big as C's. Now, looking at the diagram is a good way to kind of eyeball and estimate which is the biggest or smallest modulus. Sometimes you will be asked to use it that way, but there's also a formula that we can use to calculate a value for the modulus. So we get out a number. Obviously, A would have the smallest number for the modulus, B would be bigger, then C would be the biggest. So we'll look at that formula now. So if we have a complex number and it's in the form A plus B I, we're asked to find the modulus. The modulus will normally be written by putting a symbol that looks like this on either side of the complex number. They look like little bookmarks, they're just lines. So that means the modulus. So to find the modulus of A plus BI, what we're going to do is get the square root of A squared, the real part of the number, plus square root of B squared, the imaginary part of the number. So here's an example of a question now. If the number Z is equal to 3 minus 6i, then find the modulus of Z. So this is our complex number, and we need to find its modulus. To find the modulus, we know we need to get the square root of the real part squared plus the imaginary part squared. So we'll do that now. The modulus of Z is equal to the square root of 3 squared, which is the real part, plus the imaginary part squared. Now it's important to make sure that any signs that are in here, if it's a negative, that we also bring that down. If it was a positive, we wouldn't have to worry so much. But we're squaring this whole number, so we're squaring its sign too. Okay, so if we square 3, we're going to get 9. And if we square minus 6, well, it's going to be 6 times 6, which is 36. And a minus times a minus, which will give us plus 36. Remember, any number that's negative, when you square it, it becomes positive. So we're looking for the square root of 9 plus 36. Now plus plus, we can just say gives us a plus. So 9 plus 36 is 45. So we can say that the modulus of Z is equal to the square root of 45. Now, if this was a number that could be simplified, say for example if it was a square root of 36 or a 49, then we'd of course simplify that. But because we can't simplify this into a nice whole number, we'll just leave it as it is. So again, just to talk you through it, to get the modulus of Z, we squared the real part, we squared the imaginary part. We simplify that out, and then we get our answer.